Welcome back, everyone. Today we're going to be going over the volume of spheres. The sphere is a third shape in our volume unit, and they're all built around, if you remember the formula for the cylinder, they're all built around that formula. So what is a sphere? In case you've forgotten, it's just a ball basically, right? There's a wrecking ball, soccer ball, there's the earth, and it's basically a round solid figure where its surface hits every point. Basically, the center point is equidistant to every point on the surface. So, for example, and here you see the radius, and a perfect sphere would have the same radius no matter which direction you go, right? So it could be coming towards you, it can be going away from you, but it's always going to have the same radius. Okay. So if a cylinder and a sphere have the same diameter and the same height, what's the size of the sphere compared to the cylinder? So I'm going to show you guys a brief video. And in this video, it's going to illustrate to you how many spheres would fit into a cylinder. Okay. Oops. Let's just play this. So as you can see, that sphere was completely filled with water, and now it's being emptied out into a cylinder that's the same height as the sphere and the same diameter, also same radius. So as you can see, it filled up 2/3. It went up to this marker, right? Let's get to the end of that video one more time. Ugh. Hold on. So it went to about right there. Okay. So many ads. There you go. So it went to 2/3 of that cylinder, right? So at this point, normally we do this with a partner in class, but I want you guys to fill in these blanks at the top here underneath where it says right partner. It says fill in the equation basically for the sphere. So ask yourselves, how many spheres did we see filled up with water? And then it equaled how much of a cylinder? Okay, go ahead and pause the video. Take a few seconds to fill this in. Okay, so you should have identified that one full sphere filled with water filled in 2/3 of a cylinder, right? So then the next part says, what is the formula for the volume of a cylinder? The volume of a cylinder, as you recall, is pi r squared times height. Okay? So together, what could be the formula for the volume of a sphere? Well, if we got one sphere, the volume of one sphere equals what? 2/3 of a cylinder. Oops. And we know what the formula for the cylinder is, because we've done it with the last two lessons, right? So that's it. The volume of a sphere, all you gotta do is you take the cylinder, multiply it by 2/3. Okay, super easy. Now, side note, recall when we did the volume of a cone, right? The cone was pi r squared over 3. So now the only thing that we're doing to get the sphere is we're just going to take that same cone formula and multiply it by 2. Okay, so super easy. The only thing really, the formula you got to remember is that one. which is the formula for the cylinder. Okay, from the cylinder, we divide it by 3 to get the cone. Then we multiply it by 2 to get the sphere. Okay, so everything derives from the formula of a cylinder. Okay, so if you actually look up the formula of a sphere on the internet, you would see it as 4/3 pi r cubed, right? It's the exact same thing as this, and I can try to explain that later. But once we get to an example, it'll make more sense. Okay, let's go to the next slide. So here we go. Find the volume of a sphere with a radius of 4 centimeters. So we're going to go back to our formula. Volume of a sphere is 2 pi r squared times height over 3. So 2/3 times pi r squared times height. The radius here is 4. And so when we fill this in, I'm going to fill in 4 for the radius. And then the height, well, what's the height? Hopefully, you can see that the height, well, from top to bottom here, right? What is that height? Well, if you turn the screen sideways, you might see the radius as this, as a 4, right? If I turned it sideways, that is now a 4. It looks like an H line. Let me rewrite it properly, like that. Well, if that's the radius, what's the diameter? The diameter is 2 of the radii, so its diameter is going to be 8. 4 plus 4 is 8, right? Or 2 times 4 is 8. Well, in this case, because it's a sphere, is the diameter not also the height as well? Right? You roll it on its side, however tall it is just twice the radius. So the height is going to be the diameter here. So we're going to fill in 8. And this is where, on that last example, I told you guys, if you look up the formula on the internet, you're going to get 4/3 pi r cubed. So the only difference between this and what you would see on the internet, the reason why we give it to you this way is because it's much easier to think of, because you just have to know the formula for the cylinder, right? And then from there you multiply it by 2/3. So here's what you would see on the internet. You would see, or here's how we'll get the equation to look like the one on the internet. Our equation is 2/3 pi r squared times height. Well, what was another way to say our height here? Our height is the radius times 2, right? So 2 times the radius. So within that, if I were to multiply my numerator, I would get 2 times 2 is 4. Then I would get pi, and then r squared times r would be r cubed. And I would get that denominator of 3. So this is what you would get on the internet if you looked at the formula for a sphere. But again, I like to keep it simple. Why not just know one formula, which is a formula for the cylinder, and then multiply it by 2/3, right? So let's just solve this. I'm going to get 2 pi times 4 squared is 16 times 8 all over 3. Okay, and it does say round to the nearest hundredth, so we're not going to leave this in pi form. We are going to multiply this and round it to the nearest hundredth. So I have 2 times pi times 16 times 8, and then that's 256 pi divided by 3. Okay, so 256 pi over 3. Oops. Alright, sorry about that. Dropped my phone / calculator. The answer is going to be 268.08, and this is in centimeters, so I'm going to say centimeters cubed. All right, there's your answer. All right, let's move on to the next example here. So the key takeaway from this one is you got to know how to find your height. Your height is just you multiply your radius by 2. Okay, so why don't you guys pause the video, attempt this problem, and then come back when you are done. Okay, so this one is a pretty straightforward problem. Our radius is given. The radius is 3, and then the height, we just double that. It's going to be 6. Plug everything into the formula. You would get 36 pi feet cubed. Okay. Again, you want to use a calculator. Make sure, especially if it's asking you to round it to the nearest tenth. Here it says to leave your answer in terms of pi, so therefore I'm leaving pi right there. Okay. All right, let's move on to the next one. So now we have a hemisphere, right? Hemisphere, you think of the Earth, you have the northern hemisphere and the southern hemisphere. And in this case, it's basically just half of a sphere. So it's asking you to find the volume of half of a sphere, right? So how would you find that? Right? So pause and think about that for a second. If I have a sphere and I want to find the volume of only half of it, what would I do? Well, you would take the formula for a sphere and then do what to it? Well, you just divide it by 2. So whatever your final answer is, right, at the very end, you're going to divide it by 2. And that's going to be how you get the volume of a hemisphere, because it's half of a sphere. So this problem says round to the nearest hundredth. That means we do not want to leave it in pi. We want to solve it all the way. So let's just do this real quickly. I want you guys to pause the video. When you're done, come back. Alright, so here's what I got. The radius is 9, so that means the height, we must double that. We're going to get 18. And then I plugged it into the formula. 9 squared is 81. And using a calculator, all of that in that green circle equaled 972. And then, of course, we've got to now divide it by 2 because we only want half of that sphere. So I got the volume of the entire circle, which is 972 pi. Now I only want half of that, hence that's why I'm dividing by 2. So I get 486 pi. And then it says to round to the nearest hundredth, so on my calculator I get 1,526.81. And then this is going to be how many units? Centimeters. So I'm going to say centimeters cubed. Okay? And there's your final answer. Let's move on to the next one. Okay. So this question is a little tricky. It says a cylinder has a diameter of 16 inches and a height of 12 inches. What is the volume of the largest sphere that will fit into this cylinder? Leave it in terms of pi. So let's just say you have this cylinder. So you think of, I don't know if you ever played tennis. You know, when you buy tennis balls, they come in 3 in a pack and they come in a cylindrical shape, a cylindrical container. So you can kind of think of it like that. You've got a cylinder. It's basically asking you to fit, what's the biggest sphere that you can fit inside that cylinder? And it has to completely fit, right? Meaning part of that sphere can't be sticking out of the cylinder from the top. So I want you guys to think about this problem, pause the video, and try to solve this. What's the biggest sphere that would fit inside this cylinder? Come back when you're done. All right. So this problem is a little bit tricky because you could get it wrong if you use the wrong value for your radius, right? So even though, let's look at the diagram here, even though the diameter of the cylinder is 16 inches, we can't really use that for our height, because or our height for the sphere, because if we had a height of a sphere for 16 inches, that means when it's standing up, if we measured it vertically, it would be a lot more than the actual height of the cylinder. So the sphere, if we had a sphere that had a height of 16 inches, it would stick out of that cylinder because it would be too tall, right? So the maximum size that we can use for the sphere, it's going to be the height of 12. So if the height is 12 within this sphere, there's a height of 12. That means the radius is going to be half of that, right? So we're just going to plug those two values in, and we solve, and eventually we'll get 288 pi inches cubed. Okay, so you just got to be careful to not use the value of 16 as your height, right? Because it will stick out. All right. I believe that is our last problem for this lesson. Yes, it is. So at this point, I want you guys, as a closure problem, I want you guys to go back around your house, find a ball that you have, whether it's a soccer ball, basketball, baseball, not a football, because it's not a spherical shape, right? So any ball that you guys have, want you to try to find the volume of that ball. Okay, so grab a ruler if you have a ruler. This is how it's the only way it's going to work. So you have to have a ruler as well. So measure the radius. If you're not sure how to measure the radius, maybe try to measure the height, right? And from the height, you can find the radius. And then find the volume of that ball. And it's a good practice for you guys, and it's something that you can show off to your brother or sister or your parents or something. All right, that wraps it up for today, guys. Have a great day. Bye.